Today let us discuss one of the very important chapter, that is alkyl halides. Let us study about the alkyl halides. These are the compounds derived from hydrocarbons by the replacement of one or more hydrogen atoms by corresponding number of halogen atoms. They are also known as halogen derivatives. Here you can see here there is a alkyl halide. Its name is chloromethane. It is obtained by replacement of hydrogen atom of the methane with the chlorine. This is a alkyl halide. One more, it is a chloroform. Here, three atoms of hydrogen of methane is replaced with three atoms of the chlorine. Hence, you will be getting chloroform. We'll call it as a alkyl halides. Let us discuss the classification of halogen derivatives, and they are classified as alkyl halides, alkenyl halides, alkynyl halides and aryl halides. What is meant by alkyl halides? These are the halogen derivatives with no double bond or triple bonds, and alkenyl halides are the halogen derivatives with a double bond, and alkynyl halides with a triple bond, and aryl halides will be having benzene ring. Again, these alkyl halides are classified into monohalides, dihalides, trihalides and tetrahalides. That means if the alkyl halide is having only one halogen atom, we will call it as monohalides. If it is having two halogens, then dihalides. If it is having three halides, then it is trihalides. If it is having four halogens, then it is tetrahalides. Again, these monohalides are classified into primary halides, secondary halides and tertiary halides. If halogen is attached to primary carbon, then we will call it as primary halides. If it is attached to secondary carbon, then we will call it as secondary halides. If it is attached to tertiary carbon, then we will call it as tertiary halides. Just try to remember the classifications. General method of preparation of monohalides. In the present chapter, we will be discussing about only monohalides. And the first method for the preparation of monohalide is by direct halogenation of alkanes. Here, direct halogenation is done by UV light in presence of UV or sunlight. And here, alkane is made to treat with halogens in presence of UV light. Hence, you will get alkyl halide as the product. Here, a simple substitution reaction where hydrogen is substituted with chlorine. You can see hydrogen of alkane is substituted with the chlorine to give alkyl halide, or in this case it is alkyl chloride. Next method, by the addition of HX, that means it may be HCl, HBr, HI, HF. By the addition of HX on alkenes. Here addition will take place according to Markovnikov's rule. You can see HX is added across CC double bond, and this addition will take place according to Markovnikov's rule. Now let us see what is Markovnikov's addition. That means positive part is added to carbon having more number of hydrogen, and negative part is added to carbon having less number of hydrogen. During the addition, positive part is added to the carbon having more number of hydrogen, and negative part is added to the carbon having less number of hydrogen. Here you can see in HX, H is positively charged, that means H plus, and X is X minus. You can see in the product, H is added to carbon having more number of hydrogen. That means H is positively charged, it is added to carbon having more number of hydrogen. And X will be in the state of X minus and it is added to carbon having less number of hydrogen. Here you can see it is added to carbon having less number of hydrogen. In this reaction you will be getting isopropyl halide as the product. Isopropyl halide as the product. Try to write down both the reaction. These are very important. Try to write both the reaction. Next method is from alcohols. By the action of hydrogen halides on alcohols. Here alcohol is made to react with HX. It is a hydrogen halide in presence of zinc chloride. In presence of zinc chloride, here alcoholic group is substituted with halogen group. Halogen. Here alcoholic group OH is substituted with X. Here reactivity is directly proportional to stability of intermediate carbocation. Here reaction will take place via formation of carbocation. More the stability of the carbocation, reactivity is more. We know that tertiary carbocation is highly reactive compared to secondary and secondary is highly reactive compared to primary. Hence, tertiary alcohol will react faster compared to secondary and secondary will react faster compared to primary because tertiary alcohol will give rise to tertiary carbocation. We know that reactivity is directly proportional to stability of carbocation. Here tertiary alcohol will give rise to tertiary carbocation. We know that tertiary carbocation is highly stable. Hence, tertiary alcohol is highly reactive. And secondary carbocation is less stable compared to tertiary carbocation. Hence, secondary alcohol is less reactive compared to tertiary alcohol. Similarly, primary alcohol. Next, we can compare the reactivity order based on HX, hydrogen halides. Here, HI is more reactive compared to HBr and HBr is more reactive compared to HCl. HI is greater than HBr and HBr is greater than HCl. Try to remember these 2 points and the conversion. This is very important. Conversion and this reactivity order is very important. Next, by the action of phosphorus halides. Here it will follow SN1 mechanism. When alcohol is treated with phosphorus halides, it will give alkyl halide. Alkyl halide. You can see alcohol is treated with PCl5 to give RCl. It is a alkyl chloride. Along with alkyl chloride, you will be getting POCl3 and HCl. POCl3 and HCl. If you are doing the reaction with PCl3, you will be getting H3PO3. H3PO3. Try to write down both the reaction and it will follow SN1 mechanism. It will follow SN1 mechanism. Next point, PBr3. If you have to get RBr, that means alkyl bromide or alkyl iodide, then you have to use PBr3 and PI3. But we know that PBr3 and PI3 are less stable. Thus, for the preparation of bromides and iodides, that means alkyl bromides and alkyl iodides, you will be using phosphorus plus bromine or phosphorus plus iodine separately. That means you cannot use PbR3 because it is a less stable. Instead of PbR3, you will be using phosphorus and mixture of phosphorus and bromine or mixture of phosphorus and iodine. This is very important. Since PbR3 and Pi3 are less stable, you will be using the mixtures. Next reaction, it is a Borodine-Hunziker reaction. Here, silver salt of fatty acid is made to react with a halogen in nonpolar carbon tetrachloride solvent. Carbon tetrachloride solvent. Here, COOAG. That means this will give rise to CO2 and AgX. 1x is added to R and you will be getting Rx as the product. Remember, if you know the reactant, you can directly write the product. Here, remove this COO as CO2 and add Ag to X minus. Ag react with X minus to give AgX and one more X plus add to R to give Rx. If you know the reactant, you can write the product easily. Note down the reaction. This is very important. Next, by halide exchange. The name of the reaction is Swert reaction. Here, alkyl chloride is made to react with mercury fluoride to give alkyl fluoride and mercury chloride. Here, there is a halide exchange between alkyl chloride and mercury fluoride. Here, chlorine is replaced with the fluorine and fluorine is replaced with the chlorine. This is a simple reaction where chlorine is replaced with the fluorine and fluorine is replaced with the chlorine. You can see in the product and the reactant. Just note down the reaction and the name of the reaction. Always remember, for a Swert reaction, reagent is mercuric halides. Mercuric halides. Next, let us study the physical properties of monohalides. The lower members like or methyl fluoride, methyl chloride, methyl bromide or ethyl chloride and ethyl fluoride are gases at room temperature. And methyl iodide and members up to C18 are colorless, sweet smelling liquids. Sweet smelling liquids. They have higher boiling point than the parent alkanes. The decreasing order of boiling point is, always remember, alkyl iodide will be having higher boiling point compared to alkyl bromide, then alkyl chloride, then it comes alkyl fluoride. And among isomeric alkyl halides, decreasing order of boiling point is primary is greater than secondary and secondary is greater than tertiary. Among isomeric alkyl halides, decreasing order of boiling point is primary is greater than secondary and secondary is greater than tertiary. And decreasing order of density. Always alkyl iodide is highly denser compared to alkyl bromide, then alkyl chloride, then alkyl fluoride. Among, just note down these 2 points. These are very important. What is a boiling point, decreasing order of boiling point and the decreasing order of density? Both are same. But among isomeric alkanes, alkyl halides, the order is primary greater than secondary, then tertiary. Just note down these 3 points. These are very important. Alkyl halides, that means Rx, are polar covalent compounds but insoluble in water. Even though they are polar, they are insoluble in water because they cannot form hydrogen bonds. Alkyl halides burns with green flame due to interaction of halogen with the copper wire. This test is known as Beliston test. Rx burns with the any alkyl halide burns with the green flame due to interaction of halogen with the copper wire. Halogen with the copper wire, because you're taking some amount of the alkyl halide in the copper wire. When you keep this substance to fire, it will give green flame because of the presence of halogen. Stability order. Always remember, alkyl fluorides are highly stable compared to alkyl chlorides, then alkyl bromides, then alkyl iodide. RF is highly stable. RF is highly stable. And alkyl iodide is least stable and darken in light due to photo decomposition. They are kept in a dark light because they will undergo photo decomposition to form alkane. They will undergo photo decomposition. Write down these 2 points. These are very important. Beliston test and stability order. Chemical properties, and very important reaction it will undergo, that is nucleophilic substitution reaction or SN reaction, because of the polarity of the CX bond. Due to electronegativity difference between carbon and halogen, this CX bond is highly polarized. Hence, it will undergo nucleophilic substitution reaction. Due to high polarity of CX bond, nucleophile can attack the carbon. This carbon can be attacked by nucleophile because this carbon is having partial positive charge. Hence, nucleophile can attack this carbon and it can remove the halogen. Hence, always alkyl halides have higher tendency to undergo nucleophilic substitution, because here in the alkyl halides CX bond is highly polarized, hence carbon will get partially positive charge, hence there is a high possibility of attack of nucleophile on that positively charged carbon and elimination or removal of halogen as X minus. Here there are two types of nucleophilic substitutions. They are SN1 mechanism and SN2 mechanism, or else you can call it as, here nucleophilic substitution can take place by two ways. They are SN1 mechanism or by SN2 mechanism. For both, the reactivity order is tertiary is greater than secondary and secondary is greater than primary. Secondary is greater than primary. Remember, always tertiary will undergo SN1 reaction and secondary can undergo both SN1 as well as SN2, but always remember primary will undergo SN2. Tertiary is SN1, primary is SN2. Primary is SN2 and tertiary is SN1, and secondary is both. It can undergo both the reactions. Let us study about the SN1 mechanism. SN1 stands for unimolecular nucleophilic substitution. Unimolecular nucleophilic substitution. Here mechanism involves two steps. Let us study this mechanism by considering the hydrolysis of tertiary butyl bromide with aqueous NaOH. That is important, aqueous NaOH. Aqueous NaOH. Step 1. Here alkyl halide ionizes to give a planar carbonium ion or carbocation. Carbonium ion or carbocation. Remember, we can call carbocation as a carbonium ion. This carbocation is planar. because central carbon is sp2 hybridized. In the first step, this alkyl halide will give planar carbocation. Here plain center carbon is sp2 hybridized, hence this molecule is planar. Write down the first step. It is a formation of planar carbocation. In the next step, nucleophile can attack the planar carbon or carbocation from either side. Here, nucleophile can attack planar carbocation from both the sides, above the plane or below the plane. That means it can attack from above the plane or from below the plane. Hence, it will give rise to two products. Both are tertiary alcohols but differ in the stereochemistry. If it OH minus attacks from above the plane, it will give rise to one product. If it attacks from below the plane, it will give rise to one more product. Hence, there are two products. Let us see some of the important points of SN1. Here, ionization is the rate determining step. Here, first step. That means formation of carbocation. It is a rate determining step and slow step. In other words, the rate at which alcohol is formed should depend upon the concentration of the alkyl halide. The formation of alcohol is merely or purely depends upon the concentration of tertiary alkyl halide, because rate determining step is the ionization step of the alkyl halide. It is obvious that reaction will follow first order kinetic, therefore reaction is called SN1. And next point, the reactivity order of SN1 reaction is directly proportional to stability of the carbocations formed. Reactivity order of SN1 reaction. Reactivity is depends upon the stability of the carbocation form. Always remember, we know that benzyl halide will give rise to benzyl carbocation, which is highly stable, and allyl halides will give rise to allyl carbocation, and tertiary halide will give rise to tertiary carbocation, and secondary halide will give rise to secondary carbocation. Primary will give rise to primary carbocation, and methyl halide will give rise to methyl cation. Hence, reactivity order of benzyl halide is greater compared to allyl halide, then tertiary halide, then secondary halide, then primary halide, because benzyl cation is highly stable, then allyl cation, then tertiary cation or secondary carbocation, primary carbocation, and methyl carbocation. Hence, as we know that reactivity order is directly proportional to stability of carbocation, it will follow this order. It will follow this order. Write down, this is very important. If alkyl halide is optically active, if the alkyl halide what you have taken, if it is optically active, then SN1 reaction lead to racemization. That means it will give rise to racemization or racemic product. Next, let us study about the SN2 mechanism. SN2 stands for bimolecular nucleophilic substitution. In this type of nucleophilic substitution, there occurs bond making and bond breaking simultaneously. Here, it will take place in only one step. There is a making of bond and there is a breaking of bond. Here you can see, as the OH minus approaches from behind, the Br minus will start to move away. Br or bromine atom will start to move away. Here you can see it will give rise to transition state. At the end, bromine will go out as a Br minus and it will give rise to alcohol. It will give rise to alcohol. Write down the mechanism. This is very important. Here, reactivity of alkyl halides in SN2 substitution is governed by steric factor or bulkier group around the carbon. Here, in the previous case, it was reactivity of alkyl halides depends upon the stability of the carbocation. In case of SN2, it depends upon the steric factor. Hence, reactivity order of alkyl halides varies as follows. Methyl halides are having higher tendency to undergo this reaction than primary halides, then secondary halides, then tertiary halide. As we know that reactivity order depends upon the steric factor. Lesser the steric factor, more will be the reactivity. Lesser the steric factor, more will be the reactivity. Here CH3X, there is no steric factor, hence it will undergo SN2 readily. But in primary halides, there is a slight steric factor because of the presence of alkyl group. In primary halides, there will be alkyl group. It will cause some steric hindrance. Hence, it will undergo SN2 but with a less tendency. Here, it will follow the same pattern, secondary, then tertiary. And order of reactivity among primary alkyl halide is, this is very important. We know that primary halides will have higher tendency to undergo this reaction. In the primary halide, what about the tendency? We can have several type of primary halides. What is the tendency? Here you can see always CH3X with a less steric hindrance will undergo this reaction more readily. CH3X is having higher tendency than C2H5X, then C3H5X. In case of alkyl halide, if it is optically active, if the alkyl halide is optically active, then SN2 reaction lead to Walden inversion. Walden inversion means change in the configuration. If you start the reaction with the R isomer, and your product will be S isomer. If you start with the S isomer, your product will be R isomer. This is called Walden inversion. Thus, in short, tertiary alkyl halides react by SN1 because it will give rise to more stable tertiary carbocation. Primary by SN2. There is no doubt primary will react by SN2 and secondary by either SN1 or SN2 depending upon the nature of alkyl halide and the reagent. Depending upon the reagent and the alkyl halide, secondary will undergo SN1 or SN2. Write down all the important points. These are very important. These points are very important. And for a given alkyl group, the order of reactivity is, that means Ri, alkyl iodide, is greater than alkyl bromide, and alkyl bromide is greater than alkyl chloride, and alkyl chloride is greater than alkyl fluoride. In addition to substitution reaction, alkyl halide also undergo elimination reaction to form alkene with the removal of hydrogen halide. This reaction we will call it as a dehydrohalogenation, removal of hydrogen and halogen. In dehydrohalogenation, hydrogen and halogen atoms are eliminated from two adjacent carbon atom, and this reaction is known as beta elimination. It may proceed E1 or E2 mechanism. E1 means there will be a formation of carbocation. E2 means there is no formation of carbocation. It is analogous to SN1 and SN2 mechanism. And the order of elimination reaction is tertiary is greater than secondary and secondary is greater than primary. Remember, always tertiary halides tend to react by elimination and primary halides by substitution. Always tertiary halides try to react by elimination reaction and secondary halides or primary halides by substitution and secondary halides by either of both. It may undergo substitution or elimination depending upon the reagent and alkyl halides. Depending upon reagent and alkyl halide. Hence, we know that in addition to the substitution reaction, sometimes elimination reaction also may takes place. It will occur in two ways, that is E1 and E2. E1 means there is a formation of carbocation. E2 means there is no formation of carbocation. And order of reactivity is tertiary is greater than secondary and secondary is greater than primary. Primary alkyl halides will react by substitution reaction and secondary halides will react either by substitution or elimination depending upon the reaction condition. Let's see the elimination reaction. Here we know that alkyl halides also undergo elimination reaction in presence of base as a nucleophile. You can see here this nucleophile will act as a base and it will remove the proton. As it removes the proton, these two electrons are donated to this bond and there is a elimination of chlorine. Hence, it will give rise to alkene and let us study some of the nucleophilic substitution reaction. A first reaction. Reaction of alkyl halide with water, boiling water. Here X is replaced with the OH. X is replaced with the OH to give alcohol. In the next case, alkyl halide is made to react with aqueous KOH. Remember, for substitution, always we will be using aqueous KOH or aqueous NaOH. Aqueous NaOH. Here, substitution of X with the OH to give alcohol. Here, if we treat alkyl halide with the moist Ag2O, here X is replaced with OH to give alcohol. Or you can treat Rx with the KSH, alcoholic KSH to give alkane thiol. Here there are some of the important nucleophilic substitution like reaction of Rx with a soluble salt of fatty acid. Ag will combine with X to give AgX and this RCOO minus will react with R plus to give RCOOR. It is a ester. It's a formation of ester from alkyl halides. Note down all these reactions are very important. Next, these are very important concept many a time asked in CET NEET. Hence, first reaction with KCN and AgCN. Remember, when alkyl halides react with the KCN, you will be getting cyanide as the major product. Remember, cyanide. If you are treating with KCN, you will get alkyl cyanide. If you are treating alkyl halide with AgCN, it is a AgCN, then you will be getting isocyanide as the major. Isocyanide as the major product. Remember, isocyanide as the major. And reaction with KNO2 and AgNO2. If you are treating alkyl halide with KNO2, then you will be getting alkyl nitrides. Here are ONO. Oxygen is attached to alkyl group. Alkyl nitrates as the major. If you are treating alkyl halide with AgNO2, then you will be getting nitroalkane. Here nitrogen is attached to alkyl group. Hence nitroalkane as the major product. Here nitrogen is attached to alkyl chain. Here oxygen is attached to alkyl chain. Remember, these four reactions are very, very important. Next, reaction with sodium alkoxide, or we'll call it as a Williamson synthesis. When alkyl halides react with a sodium alkoxide, here there is a formation of ether. There is a formation of ether. You can see here ethyl chloride is made to react with sodium methoxide. Sodium methoxide. Hence, from sodium methoxide, there is a CH3O minus. It will act as a nucleophile. This CH3O minus will attach to this carbon and it will remove Cl minus to give this ether. Here, similar reactions are there. You can see there is a one more reaction here. CH3O minus will attack this carbon and remove the Cl to give this ether. Along with this, there is a formation of alkene. That means here CH3O minus will not act as a nucleophile. Instead, it will act as a base. Hence, it will remove the proton from here, this carbon, and it will give rise to alkene. But this is a minor product. This is a minor product. Major is ether. Major is ether. There is a formation of alkene also. This is very important. The formation of alkene is very important. Next, reaction with ammonia. You can see when we treat alkyl halide with ammonia, it will give rise to primary amine, secondary amine, tertiary amine, and quaternary amine. This reaction we already discussed in the amine chapter. Hence, it is very easy. Computation between substitution and elimination reaction. First, let us study the reactivity order of alkyl halides. For even reaction, primary is having less tendency than secondary and secondary is less tendency than tertiary. Note down all these points, these are very important. For E2 reaction, primary is less than secondary and secondary is less than tertiary. And for SN1 reaction, primary is less than secondary and secondary is less than tertiary. This is same for E1, E2 and SN1. This order is same for E1, E2 and SN1. But for SN2 reaction, primary is greater than secondary and secondary is greater than tertiary, because it depends upon the steric factor. Reactivity depends upon the steric factor. Hence, primary is greater than secondary and secondary is greater than tertiary. Let us see primary alkyl halides. They mainly give substitution. Remember, always primary alkyl halides will give substitution unless sterically hindered alkyl halide or sterically hindered base. In that cases, it will undergo elimination. Usually, this primary alkyl halides will undergo substitution. But in special cases, if there is a sterically hindered alkyl halides or base is highly sterically hindered, then it will undergo elimination. And one more point, it will not undergo SN1 reaction. It will not undergo SN1 reaction. And secondary alkyl halides, they will undergo both substitution and elimination. If there is a stronger base or bulkier base, then there is a higher percentage of elimination. If you are using higher or stronger base, if you are using stronger base or concentrated base, then it will undergo elimination. And in the elimination, most of this time it can react by both SN1 and SN2 and E1 or E2. It may follow any one of the mechanism, but if there is a usage of bulkier base or stronger base, then it will undergo elimination, then substitution. Then for tertiary alkyl halides, this will mainly react by elimination reaction. There is no doubt it will react by elimination reaction. Here there are some of the important one. SN2 or E2 is favored by higher concentration of good nucleophile or strong base. SN2 or E2 is favored when there is a usage of higher concentration of good nucleophile or strong base. These two are good nucleophile and strong bases, hence there is say possibility of SN2 or E2. SN1. SN1 or E1 is favored by low concentration of poor nucleophile or weak base. If there is a presence of poor nucleophile or weak base, then it will undergo SN1 or E1. If an alkyl halide undergoes SN2 or SN1 reaction, then SN2 will be favored by higher concentration of nucleophile. If alkyl halide is having capacity to undergo both SN2 or SN1. If you are using higher concentration of good nucleophile, then it will undergo SN2. If there is a both possibility, then if you increase the concentration of nucleophile or higher concentration or good nucleophile if you are using, then it will react by SN2. And one more point, for SN2 reaction you have to use aprotic solvent. That means it will not give proton, like carbon tetrachloride, there is no proton, or DMF, dimethyl formamide. These are all aprotic solvent. Whereas SN2 SN1 reaction is favored by low concentration of poor nucleophile or polar protic solvent. For SN1 reaction, if you want to make the reaction S11, if you want to make the reaction to be happen by SN1 mechanism, then you have to use poor nucleophile and polar protic solvent. That means you have to use H2O or methanol. This is a polar protic solvent. If you are using polar protic solvent, the reaction will follow SN1 mechanism. Next reaction, it is a Woods reaction. We already studied this reaction when a mixture of different alkyl halides like R1X and R2X is used, a mixture of alkane is formed. You can see here different alkyl halides are used. Then there is a formation of different alkanes, R1, R2, R1, R1 and R2, R2. These three are different alkanes. If Zn is used in place of sodium, then reaction is called Franklin reaction. In place of sodium, if you are using zinc, then the same reaction is called as a Franklin reaction. Then by halogenation of alkyl halide. Then next reaction, it is a halogenation of alkyl halides. Here alkyl halide is made to react with the chlorine in presence of UV light. There is a formation of, you can see here there was one chlorine atom, now it is two chlorine atoms, 3 and 4. This is a continuous reaction because it will follow free radical mechanism. Then formation of organometallic compound. Here alkyl halide is made to react with magnesium metal. Then it will form Grignard reagent. It is a organometallic compound. If you made to react alkyl halide with a zinc, it will give rise to dialkyl zinc. It's a organometallic reagent. It means there should be a bond between organic group and metal. Those type of compounds are called as organometallic compounds. Next important reaction, it is Friedel-Crafts reaction. Here you can see benzene is made to react with methyl chloride in presence of aluminum chloride, anhydrous aluminum chloride, to give toluene. This is very important. Reagent is very important. it will give toluene. Next, let us discuss about the dihalides. They have the general formula of CnH2nX2. Here, 2 hydrogen atom of alkane is replaced by 2 halogen atom. 2 hydrogen atom is replaced by 2 halogen atoms. And again, dihalides are classified as geminal dihalides and vicinal dihalides. Let us study about the geminal dihalides. Here, 2 similar halogen atoms are attached to same carbon atom. That means here halogen atom is attached to same carbon atom. Here halogen atom is attached to same carbon atom. You can see here in the example, this carbon is attached to 2 halogen atom. That means one carbon atom. That means 2 similar halogen atoms are attached to same carbon atoms. This type of molecules are known as geminal dihalides. Next, it is a vicinal dihalides. Here, 2 halogen atoms are attached to adjacent carbon atom. You can see adjacent carbon atoms are attached to halogen atoms. If the halogen is attached to adjacent carbon atom, then it is known as vicinal dihalides. General methods of preparation. By the reaction of PCl5 on carbonyl compound. When we treat acetaldehyde, it's an acetaldehyde with PCl5, you will be getting ethylidene chloride. Ethylidene chloride. It is a geminal dihalide because chlorine is attached to same carbon atom. Or you can see here, acetone is made to react with PbR3 to give 2,2 dibromopropane. 2,2 dibromopropane. Both the reactions are very important. Here there is a formation of dibromo compound. Here there is a formation of dichloro compound. Next, by the addition of halogen acids on alkynes. Here the reaction of halogen acids with the alkynes. You can see it's a symmetrical alkyne. They are taken symmetrical alkyne. When you add HBr to symmetrical alkyne, here it will give vinyl bromide. Again, if you add HBr, here addition will take place according to Markovnikov's rule. Hence, you will be getting 1,1 dibromoethane. You can see in the molecule propyne. Here in the first step, the addition will take place according to Markovnikov's rule. We know that in HBr, H is in the form of H plus and Br will be in Br minus. According to Markovnikov's rule, positive part will be added to carbon having more number of hydrogen. Hence H will be added to this carbon and bromine will be added to this carbon. Again this vinyl bromide is added, or this propenyl bromide is added with HBr to give dibromopropane. Here also addition will take place according to Markovnikov's rule. A simple addition according to Markovnikov's rule. Preparation of vicinal dihalide. By the direct addition of halogen to alkenes. By the direct addition of halogen. Here you can see bromine is added across this CC double bond to give vicinal dihalides. Vicinal dihalides. Or by the action of PCl5 on glycols. Here there is a glycol. When we treat this glycol with PCl5, we will be getting vicinal dihalides. Vicinal dihalides. You can see OH is replaced with the Cl. In both the cases, OH is replaced with the Cl. Physical properties. Here lower members are colorless, oily liquids with a sweet smell. Here lower members of dihalides are colorless and oily liquids with a sweet smell. And reactivity of geminal dihalides is lesser than vicinal or monohalides. Reactivity of geminal dihalide is lesser than the vicinal dihalide. Reason is, in presence of one halogen atom, strong attracting minus I effect will be there. That means in presence of one halogen atom, you cannot replace other halogen atom because of the strong minus I effect. Because of the strong minus I effect, you cannot replace one halogen atom in presence of another halogen atom. Chemical properties. Reaction with the cation. Here they are given reaction for both geminal and vicinal. Here when we treat vicinal dihalides with the cation, we will be getting cyano compound. We know that when we hydrolyze the cyano compound, we will be getting acids. When I hydrolyze this, you will be getting acid, diacids. And when we heat these diacids, you will be getting anhydrides. You will be getting anhydrides. This is a very important reaction, formation of succinic anhydride. But when the reaction is for geminal dihalides, reaction will follow different. That means here we will be getting diacids. Again when we heat it, you will be getting, here you will be getting dicyano compound. Here we will be getting diacids. But when we heat this, we will be getting acid. In the previous case, it was anhydride, but here it is acid. Here it is acid. Write down both the reaction. These are very important. Next, action of KOH or NaNH2. Here geminal dihalides or vicinal dihalides or geminal dihalides both will give alkyne. Alkyne as the final product. Alkyne as the final product, and you should remember the reagent. You should use both alcoholic KOH and sodamide. Both are very important. Next, action of KOH. When we treat vicinal dihalides with the aqueous KOH, you will be getting glycol. Cl is replaced with the OH. Hence, you will be getting glycol. But when we treat geminal dihalides with the aqueous KOH, you will be getting aldehyde. You will be getting aldehyde. Remember, if we treat geminal dihalides with the aqueous KOH, you will be getting aldehyde. If we treat vicinal dihalide with the aqueous KOH, you will be getting diol or glycol. Here you might be knowing there is a formation of OH groups. Here 2X atoms are replaced by the OH, 2 OH atom. We know that 2 OH group on one carbon atom is not stable. Hence it will undergo elimination of water to give aldehyde. In both the cases, there is a elimination of water to give aldehyde. Next, let us study about the Grignard reagent. General method of preparation of Grignard reagent. Grignard reagents are prepared in the laboratory by the action of alkyl halide on magnesium metal in presence of dry ether. Here alkyl halide is made to react with the magnesium in dry ether to give Grignard reagent. The ease of formation of Grignard reagent is maximum for alkyl iodide, then alkyl bromide, then alkyl chloride. Here there are some of the reaction of Grignard reagent. When we treat Grignard reagent with oxygen, you will be getting primary alcohol. When we treat it with formaldehyde, we will be getting primary alcohol. When we treat it with epoxide, it's a ring containing oxygen. We will call it as epoxide. We will be getting this R in the Grignard reagent. Actually, this alkyl group is a nucleophile. Here, alkyl chain will attack this carbon and break the ring to give primary alcohol. This bond R minus will attack this carbon and this bond will be shifted like this and it will be giving alcohol. Again, if you treat it with aldehyde, you will be getting primary alcohol. Or if you treat it with ester, you will be getting alcohol. But here it is a secondary alcohol. If you treat it with ketone, then tertiary alcohol. Or if you treat it with cyanide, then you will be getting ketone as the product. If you treat it with cyanide, you will be getting ketone as the product. These are the some of important reactions. 1, 2, 3, 4. These 4 reactions are, or 5 reactions are very important. These 5 reactions are very important. Here there is some more reaction. Reaction of alkyl or Grignard reagent with alkyl halide. When it reacts with alkyl halide, it will give RR. But when we treat alkyl halide with any base, here it is amine, or if you treat it with alkyne, that is acetylene. Acetylene, you will be getting alkane as the product. This R and H to give alkane. And it will react with chloro compounds, alkynyl chlorides to give alkene as the product. And it will react with chloroamine to give primary amine. Here there is a reaction with halogen to give alkyl halides. Next, the last concept, it is aryl halides. If halogen atom is directly attached to the benzene ring, then the compound is called as haloarenes or aryl halides. You can see halogen is directly attached to benzene ring, hence it is called as a haloarene. General methods of preparation. First, from halogenation of the benzene. Here benzene is halogenated in presence of AlCl3 to give chlorobenzene. Next, from phenol. When we treat phenol with PCl5, you have studied already this reaction of alcohol with PCl5. This will apply to the phenol also. Phenol will react with the PCl5 to give chlorobenzene. Write down both these reactions. These 2 reactions are important. Next, Sandmeyer's reaction. Here, diazonium chloride is made to react with CuCl to give chlorobenzene. Here, diazonium chloride is made to react with CuCl to give chlorobenzene. Or if you treat it with CuBr, then you will be getting chloro or bromobenzene. Next, Hornstecker reaction. This reaction also you have studied. Silver salt of acid in presence of halogen to give alkyl halide. Chemical properties or physical with the chemical properties. Chlorobenzene is essentially inert to aqueous sodium hydroxide at room temperature. If you find any reaction of chlorobenzene with aqueous NaOH, then there is no reaction. Aryl halides are less reactive than alkyl halides in nucleophilic substitution. Aryl halides are less reactive than alkyl halides. The carbon halogen bonds of aryl halides are too strong and aryl cations are high in energy to form it SN1 type of reaction. Here carbon halogen bond is stronger and the aryl cation formed is high in energy, hence it is less stable, hence it will not allow SN1 type of reaction. Dawes process. Next reaction is Dawes process. If we treat chlorobenzene with aqueous KOH, but the pressure should be very high and it is at a high temperature. Remember this reaction at high temperature to give phenol as the product. And one more point, presence of deactivating group. Deactivating group means electron withdrawing group in ortho and para position makes nucleophilic substitution easier. Electron withdrawing group makes the nucleophilic substitution easier. Here you can see there is a 3 electron withdrawing group, but 2 here 1 there is no. Hence the reactivity order of this trinitro compound is very high because there is a 3 electron withdrawing group. More the electron withdrawing group, more will be the nucleophilic substitution tendency. More will be the nucleophilic substitution tendency. Next reaction, Woods fatigue reaction. Here aryl halide is made to react with alkyl halide in sodium in presence of dry ether to give this product. Aryl alkyl product. Aryl alkyl product. Next, with the chloral. How chlorobenzene will react with the chloral to give DDT. This is very important reaction. The reaction of chlorobenzene with the chloral to give DDT. Next, reduction. When aryl halide is reduced in presence of nickel and aluminium in presence of NaOH to give benzene. Alkyl halide is reduced to benzene. Next, formation of aryl magnesium halide. That means formation of Grignard reagent. When we treat chlorobenzene with the magnesium in presence of THF, that means tetrahydrofuran. It's a ether type of compound. Here we will be getting C6H5MgCl. It's a Grignard reagent. Next, electrophilic substitution reaction. The first reaction is Friedel-Crafts reaction. Here hydrogen atom of benzene is replaced with the or substituted with the CH3 group. Here we know that chloro is ortho para directing group. Hence we will be getting two products. One ortho product, here it is a para product. Ortho and para product. Because of the presence of chlorine, and chlorine is ortho para directing group. Let us discuss some of the questions related to alkyl halides. Here comes the first question. On treating a mixture of two alkyl halides with the sodium metal in a dry ether, 2-methyl propane was obtained as the product. The alkyl halides are option A, chloromethane and chloroethane, option B, chloromethane and 1-chloropropane, option C, 2-chloropropane and chloromethane, option D, 2-chloropropane and 2-chloroethane. Try to find the answer. Let us discuss the solution for this question. Answer is option C, 2-chloropropane and chloromethane. When we treat 2-chloropropane and chloromethane, you will get 2-methyl propane. 2-methyl propane. Here it will undergo Woods reaction to give 2-methyl propane, and our solvent should be dry ether. Our solvent should be dry ether. Question number 2. Which of the following statements about benzyl chloride is incorrect? Option A, it is a lacrimatory liquid and answers Liston's test. Option B, it gives a white precipitate with alcoholic silver nitrate. Option C, it is less reactive than alkyl halides. Option D, it can be oxidized to benzyl aldehyde by boiling with copper nitrate solution. Find the best possible answer. Let us discuss the solution for this question. Answer is option C. It is less reactive than alkyl halides. We know that reactivity of alkyl halides depends upon the stability of the cation, stability of the carbocation. Here benzyl chloride will give rise to benzyl cation, which is highly stable. Hence we can tell that benzyl chloride is highly reactive, but here they are given it is less reactive than other alkyl halides. This is wrong. This statement is wrong. Question number 3. Which of the following haloalkane is most reactive? Option A 1-chloropropane, option B 1-bromopropane, option C 2-chloropropane, and option D 2-bromopropane. Find the best answer. Let us discuss the solution for this question. Answer is 2-bromopropane. We know that always secondary carbon is readily attacked by the nucleophile. This majorly this is about nucleophilic substitution. We'll assume that this question is about nucleophilic substitution. Here secondary carbon is readily attacked by nucleophile because it will give rise to secondary carbocation, and we know that Br minus is a readily leaving group. Hence our answer option D 2-bromopropane is highly reactive. 2-bromopropane is highly reactive. Question number 4. In the reaction given, the product B is option A alkyl chloride, option B aldehyde, option C carboxylic acid, and option D ketone. Let us discuss the solution for this question. Answer is option C carboxylic acid. When we treat alkyl halide with the alcoholic KCN, it will give rise to cyanide. It will give rise to RCN because it will undergo nucleophilic substitution. It will give rise to RCN. When you hydrolyze this RCN, you will be getting RCOOH. That means it is a carboxylic acid. On hydrolyzing cyanide, you will be getting carboxylic acid. Carboxylic acid. Question number 5. An alkyl halide reacts with the alcoholic ammonia in a sealed tube. The product formed will be option A primary amine, option B secondary amine, option C tertiary amine, and option D it's a mixture of all the three. Find the best possible answer. Let us discuss the solution for this question. When we treat alkyl halide with the ammonia, you will get primary amine. We know that this primary amine is still reactive and it will react with one more molecule of alkyl halide to give secondary amine. Again, this secondary amine is still reactive and it will react with one more molecule of alkyl halide to give tertiary amine. Again, this tertiary will react with alkyl halide to give quaternary ammonium salt. Hence, you will be getting mixture of all the three. Your product is having mixture of all the three. Question number 6. N-propyl bromide on heating with alcoholic KOH produces option A propane, option B propene, option C propine, and option D propanol. Let us discuss the solution for this question. Answer is propene. When we treat this bromopropane with the alcoholic KOH, remember we are using alcoholic KOH for elimination. Alcoholic KOH means it is a elimination. This molecule will eliminate a molecule of HBr to give propene. This is a molecule of propene. Hence, there is a elimination process will take place in presence of alcoholic KOH to give propene. Hydrogen from this carbon and bromine from next carbon will eliminate to give propene. Question number 7. Anisole can be prepared by the action of methyl iodide on sodium phenate. The reaction is called option A Woods reaction, option B Williamson's reaction, option C Fittig's reaction, and option D Itard's reaction. Find the best possible answer. Let us discuss the solution for this question. Answer is Williamson's reaction. It is only one reaction by which we can prepare ether. Here sodium phenate is made to react with methyl iodide to give ether. This is a ether. This is very important reaction, that is Williamson's ether synthesis. Question number 8. An organic compound on heating with CuO produces carbon dioxide but no water. The organic compound may be option A methane, option B ethyl iodide, option C carbon tetrachloride, option D chloroform. Find the best answer. Let us discuss the solution for this question. Answer is carbon tetrachloride. When we treat any compound with CuO, if that compound is having carbon, it will be converted into carbon dioxide. If that compound is having hydrogen, it will be converted into water. See here, when we treat ethyl iodide with CuO, carbon is converted into carbon dioxide and hydrogen is converted into water. But in this question they are told that when we treat compound with the C, it was producing only carbon dioxide. Hence it shows that the compound is not having hydrogen. Hence it shows that compound is not having hydrogen. That implies in the given option there is only one option which is not having hydrogen, that is carbon tetrachloride. Hence our answer is carbon tetrachloride. Question number 9. Compound which forms acetaldehyde when heated with dilute NaOH is option A 1-chloroethane, option B 1,2 dichloroethane, option C 1,1 dichloroethane, and option D 1,1,1 trichloroethane. 1,1,1 trichloroethane. Let us discuss the solution for this question. Answer is 1-chloroethane. When we treat ethyl chloride or 1-chloroethane with the NaOH, it will undergo substitution. Here chlorine is replaced with the OH. Again this will remove this will gives out the hydrogen gas to give acetaldehyde. This will use out hydrogen gas to give acetaldehyde. Hence our answer is option A, 1-chloroethane. 1-chloroethane. You can see here there is a elimination of hydrogen gas. Question number 10. Here they are given the reaction. You have to find the product D. Here they are given the options. Find the best possible answer. Let us discuss the solution for this question. Answer is methylamine. When we treat ethyl bromide with aqueous KOH, it's an aqueous KOH, it will undergo substitution to give ethanol. If you oxidize ethanol, you will be getting acetaldehyde. It's a acetaldehyde. And when we treat this acetaldehyde with ammonia, you will be getting amide. This is a amide. When we treat this amide with a bromine and alcoholic or alkaline KOH, not alcoholic, it's a alkaline KOH. It will undergo Hoffman's bromamide reaction to give amide. It's a conversion of amide to amine. Amide to amine. Question number 11. Reaction of methyl bromide with the aqueous sodium hydroxide involves. Methyl bromide with aqueous sodium hydroxide. Option A, SN1 mechanism. Option B, racemization. Option C, SN2 mechanism. Option D, inversion of configuration. Try to find the best answer, best possible answer. Let us discuss the solution for this question. It is a SN2 mechanism. Since methyl bromide is a primary alkyl halide, it will undergo reaction with sodium hydroxide by SN2 mechanism. It will follow SN2 mechanism. Question number 12. Following is the substitution reaction in which Cn replaces Cl. To obtain propanitrile, RCl should be. Their question is, to obtain propanitrile, RCl should be. Option A, chloroethane. Option B, 1-chloropropane. Option C, chloromethane. And option D, 2-chloropropane. Here their question is, what should be the R group in order to get propanitrile? They are given the conversion of RCl to RCN. You have to tell what should be the R group to convert or to obtain propanitrile. Propanitrile. Let us discuss the solution for this question. Answer is chloroethane. When we treat chloroethane with KCN, you will be getting propanitrile. 1, 2, 3. You have to count the number of cyanide also. It is propanitrile. 3 carbon atom, hence it is propanitrile. Which of the following pairs are correctly matched? Option A alone. Option B, A and B. Option C, B and C. Option D, B and D. Try to find the correct answer. Let us discuss the solution for this question. Answer is option D, B and D. Here, when Rx react with AgCN, it will give RNC, isocyanide. It will give isocyanide. And D is when we treat alkyl halide with the sodium, you will be getting alkane. Hence, B and D are correct. Here in the case of alkyl halide, when reacts with AgCN, it will give isocyanide. That is right. But when we treat alkyl halide with the KCN, it will not give isocyanide. Instead, it will give cyanides. It will give cyanides. And this is not the proper reaction. Reaction of alkyl halide with the AgOH will not give alkane. And option D is the right answer. That is a Woods reaction. Question number 14. In the given set of reactions, the IUPAC name of the product Y. Option A, N-methylpropanamine. Option B, N-isopropyl-methanamine. Option C, butane 2-amine. Option D, N-methylpropane 2-amine. Let us discuss the solution for this question. Answer is option D, N-methylpropane 2-amine. When we treat 2-bromopropane with the AgCN, it will give isocyanide. When we treat this isocyanide with LaH, that is lithium aluminum hydride, it will give this amine. It will give amine. Here isocyanide is reduced to amine. Remember, when we treat it with LaH, isocyanide is reduced to amine. Hence its name is N-methyl propane 2-amine. Propane 2-amine. N-methyl propane 2-amine. 2-amine. Question number 15. Find the product B. Here they are given the option. Try to find best possible answer. Let us discuss the solution for this question. Answer is cyclohexane. When we treat this bromocyclohexane with the magnesium in an ether medium, you will get Grignard reagent. When we treat Grignard reagent with the water, we know that this bond will break and this cyclic ring or the organic ring will gain one H plus and it will form cyclohexane. Remember, when we treat this any Grignard reagent with the water, it will give alkane or it will give organic compound. It will give organic compound and hence the Grignard will collapses. Grignard will collapse if we treat Grignard reagent with the water, because it will break organometallic bond. It will break organometallic bond and you will be getting only organic molecule. Question number 16. Which one of the following is not formed when a mixture of methyl bromide and bromobenzene is heated with sodium metal in the presence of dry ether? Option A, ethane. Option B, diphenyl. Option C, propane. And option D, toluene. It's a simple Woods reaction. Try to find the best possible answer. Let us discuss the solution for this question. Answer is propane. When we treat methyl bromide with the bromobenzene, there is a possibility of three compounds. That is, when methyl bromide reacts with this bromobenzene, you will get toluene because it's a Woods-Fittig reaction. When methyl bromide reacts with one more molecule of methyl bromide, you will get ethane. When bromobenzene react with one more molecule of bromobenzene, you will get diphenyl. Hence, you cannot get the propane in this case. Propane, this case. Question number 17. Tertiary alkyl halide is practically inert to substitution by SN2 mechanism because option A, insolubility, option B, instability, option C, inductive effect, option D, steric hindrance. Let us find the solution for this question. Answer is option D, steric hindrance. We know that during SN2 mechanism, there is an attack of nucleophile from the back to the substrate. Here nucleophile is attacking from the back to the substrate. If it is attacking from the back, then that should be less sterically crowded. That molecule should be less sterically crowded. But our tertiary alkyl halide is, there is a large steric hindrance. There is a large groups on backside. Hence, it cannot attack from the backside. Hence, there is no possibility of SN2 for the tertiary alkyl halides. Tertiary alkyl halides. Question number 18. In SN2 substitution reaction of the type, which one of the following has the highest relativity rate? Here they are given the option, find the best possible answer. It's a SN2 reaction, you have to tell the highest possible reaction rate. Let us discuss the solution for this question. Answer is ethyl bromide. It will follow SN2 mechanism. We know that for a molecule to follow SN2 mechanism, alkyl halide or the molecule should be less hindered. In the given molecules, this is the less hindered molecule. Hence, it will undergo SN2 with the fastest rate, with the highest rate. Hence, our answer is option B, ethyl bromide. Option B, ethyl bromide. Question number 19. Here they are given the addition reaction. It's the addition of HBr across CC double bond. Here you have to find the product X. They are given the option and try to find the best possible answer. Let us discuss the solution for this question. Answer is option D, 2-bromo-2-methyl-butane. Here you can see the mechanism. During this process, this double bond will abstract the proton to give carbocation. We know that always tertiary carbocation is more stable compared to secondary. Hence, hydrogen from this carbon will migrate towards this carbon with our hydride. We will call it as hydride transfer. It's a transfer of H minus. This hydrogen will jump to this carbon with its 2 electron. Hence, it will give rise to tertiary carbocation. And Br minus of HBr will attack to this tertiary carbocation to give the product 2-bromo-2-methyl-butane. 2-bromo-2-methyl-butane. If you want the mechanism, you can take. Let us go to the next question. Consider the following reaction. You have to find the product Z. Here they are given the options and try to find the best possible answer. Let us discuss the solution for this question. Answer is option D. You can see when we treat ethanol with the PbR3, here it will undergo substitution and OH is replaced with the Br to give ethyl bromide. When we treat this ethyl bromide with alcoholic KOH, we will be getting ethene because it will undergo elimination. Hydrogen from this carbon and bromine from next carbon will eliminate to give ethene. When we treat this ethene with the H2SO4, it is an addition according to Markovnikov's rule. Here we can write H2SO4 as H plus and HSO4 minus. Hence it will add across this CC double bond to give this following compound. This is the answer for this question. Let us go to the next question. Question number 21. In the following reaction, the product SX is. Let us discuss the solution for this question. When we treat this benzyl bromide with magnesium in ether medium, it will give rise to Grignard reagent. Grignard reagent. When we treat this Grignard reagent with the acid or water, it's a hydrolysis. This organometallic bond will break and it will give rise to toluene. This organometallic bond will break and it will give rise to toluene. Hence our answer is C6H5CH3. It is toluene. Here they are given three reactions. Here they are given three reactions. You can see which of the following statements is correct. Option A is substitution, B and C are addition reaction. They are telling about this reaction. Option B, A and B are elimination and C is a addition. Option C, A is elimination, B is substitution and C is addition. Option D, A is elimination, B and C is a substitution reaction. Try to find the best possible answer. Let us discuss the solution for this question. Answer is option C. You can see A is a elimination. There is a elimination of HBr to give propene. Elimination, hydrogen from this carbon and bromine from this carbon. Hence it will give rise to propene. This reaction is a elimination. Next, here Br is substituted with OH. Hence it is a substitution. In the last case, here CC bond is added with bromine, Br2. Here bromine is added across CC double bond. Hence it is a addition reaction. Hence our option C is right. Question number 22. Which of the following compounds will undergo racemization when solution of KOH hydrolyzes? Here they go in the options. Try to find the best possible answer. Option A 1 and 2. Option B 2 and 4. Option C 3 and 4 and option D 1 and 4. Let us discuss the solution for this question. Answer is 3 and 4. 3 and 4. Here you can see 3 and 4 will react by SN1 because this carbon is sterically hindered. Hence it will undergo SN1. And 4, it is obviously this will undergo SN1 reaction because this carbon is tertiary. Hence SN1 reaction is undergone by 3 and 4. We know that during the SN1 it will lead to racemization. You will be getting racemic product. Racemic product. Question number 23. Which of the following reaction is an example of nucleophilic substitution reaction? Let us discuss the solution for this question. Answer is option B. Here OH minus will attack this carbon or alkyl group to remove X. Hence you will be getting alcohol as the product. This is a nucleophilic substitution. In the present chapter, you will be studying about amines. Amines are the derivatives of ammonia in which one or more hydrogen atoms are replaced by alkyl groups, and amines are classified as primary, secondary, tertiary and quaternary. You can see these are the derivatives of the ammonia because we can get the amines from ammonia. That's why we'll call it is a derivative of amines, derivative of ammonia. If we replace one of the hydrogen atom of the ammonia with alkyl group, here R is an alkyl group, you will be getting primary amine. If you replace two hydrogen atoms with the alkyl group, then you will be getting secondary amine. If you replace three hydrogen atom, then you will be getting tertiary amines. These are the classification of the amines. They are classified as primary amine, secondary amine and tertiary amine depending upon the alkyl chain attached to nitrogen atom. And they have the general formula. The general formula of primary amine is CnH2n plus 1 NH2, and for secondary amine CnH2n plus 1 twice NH, and for tertiary amine it is CnH2n plus 1 thrice N. This is the general formula of primary amine, secondary amine and tertiary amine. Note down all these three formulas. Structure. Here nitrogen atom is sp3 hybridized. It has lone pair of electron so that the shape of the molecule is pyramidal. Here the central nitrogen atom is sp3 hybridized, and since it is having lone pair of electron, the shape of the molecule is pyramidal. It is pyramidal in shape. Let us discuss the general method of preparation. And the first method is from ammonolysis of alkyl halides and alcohols. Let us discuss the ammonolysis of alkyl halides. When an aqueous solution of ammonia is heated with alkyl halide, all the three types of amines and along with this quaternary ammonium salt is also obtained. You have to take aqueous solution of ammonia. Here I have taken aqueous solution of ammonia, and to that you have to add alkyl halide. We usually represent alkyl halide as a Rx. When we add ammonia to the alkyl halide, this ammonia, since it is having lone pair, it will act as a nucleophile. It will directly attack to this R and it will expels out this X. Hence you will be getting RNH2 with the liberation of HX. Again, this RNH2 can again act as a nucleophile. Again, it will attack over one more molecule of RX and you will be getting R2NH and with the liberation of one more molecule of HX. Again, this is highly nucleophilic. Again, it will attack over one more molecule of RX and again you will be getting R3N. This is a tertiary amine. Again, this tertiary amine will attack over RX and you will be getting quaternary ammonium salt. It is simple nucleophilic substitution. It's a nucleophilic substitution reaction. If ammonia is taken in excess, then primary amine is the main product. Just note down this point. If you have taken ammonia in excess, then primary amine will be the major product. Next, from ammonolysis of alcohol. When alcohol, will usually represent it like ROH. When alcohol and ammonia are passed over Al2O3, here all three types of amines are formed. Let us see the chemical reaction. Here alcohol is taken and NH3 is passed over Al2O3 along with ROH. You will be passing ROH and NH3 over Al2O3. You just remember here OH is replaced with NH2. Here alcohol is converted into amines. Again, this amine is treated with Al2O3 and with the excess of alcohol you will be getting secondary amine. In the similar way you will be getting tertiary amine. Remember, during this process you will not be getting quaternary ammonium hydroxide because of the steric hindrance. If excess of ammonia is used, then main product will be primary amine. Remember, if you are using excess of ammonia, then primary amine will be the major product. Don't forget, you will be using Al2O3 as a catalyst over 400 degrees Celsius. OH is converted into NH2. OH is converted into NH2. Next, by reduction. Here you have to take RCONH2. What does it mean? It is a amine. If there is a CONH2 bond, you will be calling amine. You have to take amine, you have to reduce that amine. By using a reducing agent, here they use lithium aluminium hydride, LAH, or you can use sodium in ethanol. Here just conversion of amide to primary amine. You can see CO is converted into CH2. Here CO is converted into CH2. That means amide is converted into primary amine. Here it involves a mechanism of hydrate transfer. Here hydrate from lithium aluminum hydride will attack this carbonyl and the reaction will follows. Next, by the reduction of RCN, cyanide. If you reduce cyanide in presence of sodium in ethanol, you will be getting primary amine. Don't forget, in both the cases, you will be getting primary amine as the product. You can see in place of C, you can add CH2. In place of N, you can add NH2. It's a simple way to remember this type of reaction. Otherwise, you should be doing the mechanism. Just remember RCN is converted into RCH2 NH2. Two of the hydrogen is added to C and again two hydrogen is added to N. RCH2 and NH2. This reaction is also called as Mendes reaction. Next method from reduction of alkyl isocyanates with the sodium and ethanol gives secondary amine. Here they are taken isocyanate. If we treat it with sodium in ethanol, we will be getting RNHCH3. That means it is a secondary amine. Out of 4 hydrogens, add 1 hydrogen to this nitrogen and add 3 hydrogen to this carbon. You will be getting RNHCH3. Next, from oxime. This is a oxime. When we reduce the oxime in presence of lithium aluminum hydride or sodium in ethanol, you will be getting RCH2NH2. RCH2NH2 with the liberation of water. The liberation of water. Next, from nitro compound. If you reduce the nitro compound, here you can see RNO2. If we reduce it with tin in HCl in presence of hydrogen, you will be getting amine. Remember, this is very important reaction. Just note down this reaction. It is a conversion of nitro to amine in presence of tin in HCl. This is a catalytic reduction because you are using tin as a catalyst. Tin as a catalyst. Just note down this reaction. It is a very important reaction. Here there is one more point. In lab method, we will be using tin in HCl. While in industrial method, we will be using iron in HCl. You can use both iron in HCl or tin in HCl. Both will give the amine as the product. Next, by hydrolysis. Alkyl isocyanide undergoes hydrolysis with the mineral acid and forms alkyl amine. You can see isocyanide. Cyanide means ReCl. Isocyanide means RNC. That's the difference. RNC and RCl. If you hydrolyze this isocyanide, you will be getting RNH2 and acid HCOOH. That means it is a formic acid and primary amine as the product. Primary amine and formic acid as the product. Next, from hydrolysis of alkyl isocyanate. Alkyl isocyanate undergoes hydrolysis on heating with KOH. Here also you will be getting RNH2 as the product along with K2CO3. K2CO3. Here you can see RNC is converted into RNH2. Here RNCO is converted into RNH2. Both the cases you will be getting primary amine as the product. Next, very important method, note down, it's a very important method from Grignard reagent. Alkyl magnesium iodide reacts with chloramine to yield alkyl amine. Here, this is a Grignard. When we treat Grignard with chloramine, this is a chloramine, you'll be getting primary amine as the product. Here you can see, we know that always remember in Grignard, alkyl group is a nucleophile. This is a nucleophile. It will attack over this N because it is an electrophilic center. R will attack over this N, hence it will expels out Cl because Cl is a readily leaving group, and you will be getting RNH2 as the product along with MgICl, because here R will come out of this RMgI. Now it is left out with Mg plus I. But when it attacks this nitrogen, it will give out Cl minus. This Cl minus will combine with Mg plus I to give MgICl. Hence, you will be getting primary amine as the product. Just note down this reaction. Next, very important method, Gabriel phthalimide synthesis. Phthalimide is the first treated with KOH to obtain potassium phthalimide, which is then treated with alkyl halide. Then alkyl phthalimide on hydrolysis yields alkyl amine. First, phthalimide is treated with KOH. Since it is a base, it will abstract this hydrogen and it will form a salt. It will form a salt, potassium salt. And this potassium phthalimide, which is then again treated with Ri. This whole part will act as a nucleophile and attacks over this R and expels out readily leaving I as a I minus. Hence you will be getting NR. Again, when we hydrolyze this, you will be getting phthalic acid. This whole bond will break. This bond will break. You will be getting RNH2, RNH2. This nitrogen is attached to oxygen. This bond will break. Hence, you will be getting RNH2 and phthalic acid. Phthalic acid. By Hoffman's bromamide reactions. This is a general method for the conversion of alkyne amides into one carbon less primary amine. It's a conversion of amide to primary amine, which is having one carbon less. Here you can see ethanamide is treated with bromine in excess of KOH. You will be getting amine and K2CO3, KBr and water. Here all three are byproducts. This is a major product. You can see this primary amine is having one carbon less compared to your starting amine. Here there were two carbon atom. Now it is one carbon atom. RCONH2 is converted in, or CH3CONH2 is converted into CH3NH2. You should remember the byproduct also, because K2CO3 and KBr. K2CO3 and KBr are the byproducts formed, and the reactants are, or the reagent is bromine in excess of KOH. Next, it's a Curtius reaction. Acid chloride on treatment with sodium azide. Just note down the formula of sodium azide. It will be NaN3, NaN3. And when we treat acid chloride, you know the example for acid chloride like CH3COCl. When we treat acid chloride with sodium azide, it will give acid azides. This is a acid azide, which on pyrolysis means heating at high temperature, gives isocyanate, which on hydrolysis you will be getting corresponding amines. First, you have to take RCOCl, that means acid chloride. You have to treat acid chloride with sodium azide, that means NaN3, where Cl will be replaced with the N3. Cl will be replaced with the N3. You will be getting acid azides like this, acyl azide. When we heat this acyl azide, it will give out nitrogen gas and you will be getting alkyl isocyanate. When we hydrolyze this alkyl isocyanate, you will be getting RNH2. That's a primary amine as the product. Just note down the reaction. Schmidt reaction. This is a very important reaction. In presence of concentrated H2SO4, alkonoic acid reacts with hydrozoic acid. Remember the formula of hydrozoic acid. It is HN3. HN3. You can see here HN3 to give alkyl amine. Here they have taken acid to treat it with hydrozoic acid in presence of concentrated H2SO4. You will be getting amine as the product along with nitrogen and carbon dioxide. Remember, it's only one method by which you can convert acid to amine directly. You have to remember the reagent. Anywhere, if you find this reagent, just convert acid into amine. Convert COOH into NH2. This is a reagent HN3. We know that NH3 is amine, but HN3 is a hydrozoic acid. Write down the reaction. Next, Lawson rearrangement reaction. In this reaction, hydroxamic acid undergoes rearrangement and gives alkyl amine. This is a hydroxamic acid. When we treat it with chloride, acid chloride, this O minus NOH will be there. If it leaves the proton, it will be O minus. This whole will act as a nucleophile and attack over this CO and expels out this Cl. You will be getting this product. Again, this will undergo rearrangement to give RnCO. If we hydrolyze this, you will be getting amine. This is not such an important reaction. Reductive amination of aldehyde and ketone. Here, if you have to get a primary amine, then you have to treat ammonia with the ketone. If you treat ammonia with the ketone in presence of hydrogen and nickel, you will be getting primary amine as the product. If you have to get secondary amine as the product, then you have to treat RNH2. It is a primary amine. For secondary amine, you have to treat primary amine with the ketone in presence of H2 nickel to give secondary amine as the product. If you have to get tertiary amine as the product, then you have to treat secondary amine with the ketone. For tertiary amine, secondary amine. For secondary amine, primary amine. Hence, for tertiary amine, you have to treat secondary amine with the ketone in presence of hydrogen, nickel to give tertiary amine as the product. Just note down all this reaction. This is very important. Next, physical properties of amine. Here CH3N2 methylamine is a gas and ethylamine is a volatile liquid, and higher amine will have fishy smell. Here there is a hydrogen bonding, but it is less or weaker compared to water. Boiling point. Due to small intermolecular association, the boiling point of primary and secondary amines are lower than those of alcohols. The boiling point of tertiary amines, which forms no hydrogen bond, are near to those of alkenes. Here you can see the order of boiling point. Always primary amine is greater than secondary amine and secondary amine is greater than tertiary amine. Order of boiling point. Solubility. Low molecular weight amines are very soluble in water. The water solubility of amines decreases with increasing size of alkyl group. Size of alkyl group, solubility of amine will decreases. Hence the order of solubility is primary amine is greater than secondary amine and secondary amine is greater than tertiary amine, because in primary amine there will be only one alkyl chain, hence it is highly soluble. But in secondary amine there will be two alkyl chains, hence it is less soluble. And tertiary amine will be having three alkyl chain, then it is further less soluble. Chemical properties. First, it is a reaction with acid. It reacts with the acid to form salt, because we know that our amine is a base. When it reacts with the acid, it will be giving salt. If you heat this salt to a high temperature, you will be getting alkyl halide as the product with the liberation of ammonia. Just remember, when we treat acid with the amine, you will be getting salt as the product. Reaction with H2O. It forms alkyl ammonium hydroxide with water. Ammonium hydroxide. This ammonium hydroxide are used for precipitation of second and third group cations in qualitative analysis. You can see when we treat amine with the water, you will be getting alkyl ammonium hydroxide. This alkyl ammonium hydroxide can be used for precipitation of second group and third group cation. Here you can see we can precipitate FeCl3 as FeOH thrice or AlCl3 as AlOH thrice. These are the uses of alkyl ammonium hydroxide. Reaction with alkyl halide. Alkyl amine reacts with alkyl halide and form secondary, tertiary and quaternary ammonium salt. We already discussed this reaction. Acetylation. Acetylation takes place when alkyl amine combines with acetyl chloride or acetic anhydride. Here, this amine group will act as a nucleophile and attach to this CO, and it will expel out this Cl. Hence, you will be getting RNHCOCH3. Cl will combine with the hydrogen of H to give HCl. Here, similar it is in the case of acetic anhydride. Acetic anhydride. Benzoylation. Here, in place of acetyl chloride, they use benzyl chloride. If we treat benzyl chloride with amine, you'll be getting alkyl benzamide. Alkyl benzamide with the liberation of HCl. Here also, this RNH2 will act as a nucleophile and attach to this CO and expels out the Cl to give RCONHR with the liberation of HCl. Just note down this reagent, benzyl chloride and the product. Acidic nature. Amines are very weak acids. Only primary and secondary amines show acidic nature. When we treat amine with sodium, it will be forming salt. It will be forming salt with the liberation of hydrogen. Next, very important, reaction with halogen. The hydrogen atoms of amine group are replaced by hydrogen atoms in presence of alkali solution. If we treat amine with the bromine in alkali, that means NaOH or KOH, you will be getting bromoalkyl amine. Here, hydrogen atom of amine is replaced with the halogen. It's a simple reaction. Here, hydrogen is replaced with halogen with the liberation of HBr. You can see RNH2 it was, now it is RNHBr. Here H of this amine will combine with the Br minus of Br2 to give HBr. Here there should be a presence of alkali. Should be a presence of alkali. Just note down this reaction. Next, reaction with aldehyde. Alkyl amine reacts additively with aldehydes to form alpha hydroxy amines, which are chained to Gibbs base with the elimination of water molecule. When we treat amine with aldehyde, it will be forming this product, that means RNH2. It is a nucleophile because it is rich in electron. It will attack over this carbon and this bond will shift like this, CO minus. This O minus will abstract proton of NH2 to give RNHCOH HR. Here RNH2 is this part. RNH will attack over this. It will be OH. Here OH. Hence there is a elimination of water. Elimination of this water to give double bond. Double bond we will be calling this as a Gibbs base. Gibbs base. Just note down the reaction. Next, oxidation reaction. The oxidizing agent used is KMnO4 in acidic solution. Alkyl amine on oxidation with acidified potassium permanganate forms aldimine, which on hydrolysis gives aldehyde and ammonia. If we treat the amine with oxidizing agent like KMnO4 in acidic solution, we will be getting aldimine, which on hydrolysis this bond will break and you will be getting, in place of C double bond N, you will be getting C double bond O. Hence you will be getting aldehyde as the product. In the similar case, if you are using secondary amine, you will be getting ketone as the product. When we use tertiary amine, you will be getting nitroalkane as the product. Just note down all these three reactions. First, conversion of RCH2NH2 to aldimine. Aldimine. In between C and N, you should form double bond and you should remove one hydrogen from carbon and nitrogen. RC double bond N. And when it is on hydrolysis, just form a double bond here. C double bond O, like this, RCHO. If in case of secondary amine, it will be ketone. With H2SO5, that is a Carros acid. When we treat primary amine with the Carros acid, you will be getting N-alkyl hydroxylamine, aldoxime or hydroxamic acid. If we treat secondary amine, you will be getting ketoxime. If you are treating tertiary amine, you will be getting nitroso compound. This is not such an important reaction. Next, very important reaction, that is carbyl amine reaction. When alkyl amine is heated with chloroform and alcoholic KOH, alkyl isocyanide is formed, which is having very bad smell. This test is also given by aniline. When we treat primary amine with chloroform and KOH, alcoholic KOH, this should be alcoholic, you will be getting isocyanide, RNH2, now it is RNC. It was RNH2, now it is RNC. This is a isocyanide. It will be having very bad smell. Along with this, you will be getting 3KCl and 3H2. Here it involves nucleophilic attack over CCl2. It is a dichlorocarbene. It is a mechanism. No need for that. Just remember the reaction. Conversion of RNH2 to RNC. Next, reaction with HNO2 or NaNO2 plus HCl or H2SO4. First reaction, primary amines reacts with nitrous acid to produce nitrogen gas. This is nitrous acid. When we treat nitrous acid with the primary amine, we will be getting alcohol with the liberation of N2. It is a nitrogen gas. If we are treating secondary amine with the nitrous acid, you will be getting N-nitrosoamine. N-nitrosoamine as the product. Here you can see the structure. R2NNO. Nitrosoamine. Just note down the reactions. These are very important. Primary amines give alcohol and secondary amine give N-nitrosoamine. N-nitrosoamine. And tertiary amine will give trialkyl ammonium nitrate. Trialkyl ammonium nitrate, which is soluble in water. Trialkyl ammonium nitrite. Here some of the points regarding the chapter. Nitrosoamines are carcinogens. And amines can have chiral N atom but cannot be resolved in enantiomeric form because of rapid inversion of one enantiomeric form into other. The skip base formed by reaction of primary amines and aldehyde or ketones are called anenes. The mixture of primary, secondary and tertiary amines can be distinguished by Hofmann test or Hinsberg reagent or carbylamine test. Now let us discuss about aniline. Say aniline. Aniline is also called as aminobenzene or phenylamine. Aniline was first prepared by Anveldon in 1826 by the distillation of indigo, which is called aniline in Spanish, and hence the name is aniline. General methods of preparation. And first lab method in aniline is prepared in the lab by reduction of nitrobenzene with tin and HCl. If we reduce the nitrobenzene with the tin and HCl, we will be getting aniline as the product. You know that it's a conversion of nitro to amine using tin and HCl or iron in HCl. You have already studied this reaction. Next industrial method is you're using tin in place of tin and HCl. You'll be using iron and HCl. And the third method from phenol. Aniline is obtained when a phenol is treated with ammonia in presence of zinc chloride. When we treat phenol with ammonia in presence of zinc chloride, you'll be getting aniline as the product. You have to treat phenol. It's a phenol treating with ammonia, you'll be getting aniline as the product. Next method from benzamide. Aniline is formed when benzamide is treated with bromine and KOH. It is a Hofmann's reaction. If we are treating this amide with the bromine and KOH, we will be getting aniline with 1 carbon less. You can see it was having 7 carbon atom. Now it is 6 carbon atom. Along with this, you will be getting K2CO3 and KBr. These are all repeated reactions you have already studied in the amines. Now again studying in the aniline. Next, from benzoic acid. Benzoic acid is dissolved in concentrated H2SO4 and hydrozoic acid. This is a hydrozoic acid in chloroform. When both solutions are mixed, you will be getting aniline. It's a benzoic acid in presence of hydrozoic acid and concentrated H2SO4, you'll be getting aniline. There's a conversion of COOH to NH2. Next, from chlorobenzene. Aniline can be manufactured by the action of ammonia on chlorobenzene in presence of cuprous oxide. It's a conversion of chlorobenzene to ammonia in presence of cuprous oxide and ammonia. So conversion of chlorobenzene to aniline in presence of cuprous oxide and ammonia. Cuprous oxide and ammonia. Next, from Grignard reagent. Here in the last place you had used RMgR. In place of R you had used phenyl group. C6H5MgBr will be treating with ClNH2. That means chloramine to give C6H5NH2. That is a aniline with salt. Next, preparation from benzene. If we are treating benzene with NH2OH, that is a hydroxylamine, in presence of FeCl3, we will be getting aniline as the product. Just remember how we can prepare aniline from chlorobenzene, Grignard, and from benzene. Next, from phenyl isocyanide. It's an isocyanide because NC means it is an isocyanide. On hydrolysis, you will be getting aniline along with formic acid as the product. Next, from phenyl isocyanide. If we treat phenyl isocyanide with KOH, you will be getting aniline as the product along with K2CO3. Chemical reactions. Reaction with acid. Alanine is a weak base, but it forms salts with a strong acids. It will form a salt with a strong acid. You can see when you treat aniline with a strong acid, it will give H+. You will be getting salt as the product. Alkylation. Aniline reacts with alkyl halides forming secondary, tertiary and quaternary ammonium salt depending upon the concentration of alkyl halide. When we treat alkyl or aniline with the alkyl halide, we will be getting different amines. You can see here they use secondary amine, will be getting product as a tertiary amine. Since they use primary amine, you will be getting secondary amine as the product. Here they use tertiary amine. Here the product is quaternary ammonium salt. The simple reaction, this whole aniline will act as a nucleophile and attacks to this carbon and removes the iodine. We will be getting this as a product. Here also this whole will act as a nucleophile. This NH will attack over this CH3 and it will expels out iodine. A similar mechanism, it's a nucleophilic substitution reaction. Next, it is a acylation reaction. Aniline reacts with acid chlorides or anhydrides to form corresponding amides or anilides. You can see C6H5NH2. It is a aniline. When we treat aniline with acid chlorides, here C6H5NH2 will act as a nucleophile and attach to this CO and expels out this Cl. Hence you will be getting acetanilide as the product. Or it is a similar mechanism in case of acetic anhydride. Next, reaction due to benzene ring. This is very important. First, halogenation reaction. Chlorine and bromine react with aniline to form trichloro and tribromoaniline respectively. If you are treating aniline with a bromine in a polar solvent, remember it should be a polar solvent like H2O or methanol. It should be a polar solvent. You will be getting tribromo or trichloro product. All ortho para positions are filled. If you're using this, if you're doing the same reaction in non-polar solvent, then you may get different two products. That means bromo and orthobromo product and para-bromo product. Here it was orthobromo and para-bromo in different proportions. Remember, if you are using polar solvent, you will be getting tribromo product. If you are using non-polar solvent, then you will be getting ortho and para product. Nitration. Direct nitration. The direct nitration of aniline by concentrated HNO3 and concentrated H2SO4 gives meta-nitroaniline. If you are treating aniline with a concentrated H2SO4 or HNO3, you will be getting meta-nitroaniline as the product. Remember, if you are using concentrated H2SO4 and concentrated HNO3, then you will be getting meta product. Remember, it is a meta product. This is very important. Next, indirect nitration. In indirect nitration, amino group is protected by acetylation to give acetanilide. Here, first in the first case, this amine group is protected. That means it is made to react with acid chloride. Hence, you will be getting NHCOCH3. It's a acetanilide. Then it is nitrated. In this case, you will be getting ortho and para product separately. Ortho and para product. Again, if you hydrolyze these, this NHCOCH3 bond will break and you will be getting amine as the product. Amine as the product. Ortho and para nitroamine as the product. Next, sulfonation. Aniline reacts with fuming H2SO4 to give sulfonylic acid. You can see aniline is treated with fuming H2SO4 to give sulfonylic acid. In the first case, you will be getting salt. Again, this will lose the water to give this product, and this will rearrange to give sulfonylic acid. And the last reaction, it is a catalytic hydrogenation. Aniline undergoes hydrogenation in presence of nickel at high temperature to give aminocyclohexane. Here all the aromatic ring will be converted into non-aromatic ring. Here aniline is converted into aminocyclohexane in presence of nickel at high temperature, in presence of hydrogen. Let us discuss some of the questions related to amines. Here comes the first question. In a reaction of aniline, a colored product C was obtained. What is that C? See the reaction. Here alanine is made to react with sodium nitrite and HCl, and it will give B. And again B is treated with this particular compound, that is N-N dimethyl aniline. N-N dimethyl aniline in the cold condition, and this will give rise to C. Now the question is, what is the structure of C? Here there are the options. and try to answer the question. Let us discuss the solution for this question. Answer is option B. Always when aniline reacts with a sodium nitrite and HCl, this is a diazotization reaction. Diazotization reaction. Here it will give rise to diazonium chloride. It's a benzene diazonium chloride. When you treat benzene diazonium chloride with this, it will give para product. It will give para product because this amine is a para directing group. This here it is a para directing group. Hence our product will be para product. Here this diazonium part is added to para position of this amine. Para position of this amine. Hence our option B is the right answer. If you want, write down the whole reaction. Let us go to the next question. Predict the product. And here they are given the reaction and you have to predict the product. Here options are given. Try to find the answer. Let us discuss the solution for this question. It's a simple diazotization reaction. If you use the reagent NaNO2 and HCl, they both will react to give nitronium ion, NO plus ion. We know that this is a electrophilic in nature. Hence our amine is nucleophile. Hence it will attack to this nitronium ion and it will give rise to this particular compound. Here nitrogen is in positively charged because it has donated its 2 lone pair electron. Hence it will gain positive charge. This positive charge is neutralized by hydrogen because this bond is donated to the nitrogen. Hence the nitrogen will gain the electron. Hence the positive charge is neutralized. Hence you will be getting the product this. This is a option B. So option B. Let us go to the next question. Question number 3. Nitrobenzene on reaction with concentrated HNO3 and H2SO4 at 80 to 100 degrees Celsius forms which one of the following products? Option A 1,2 dinitrobenzene, option B 1,3 dinitrobenzene, option C 1,4 dinitrobenzene and option D 1,2,4 trinitrobenzene. Try to find the answer. This is a nitrating mixture. This combination of HNO3 and H2SO4 is a nitrating mixture. Let us discuss the solution for this question. Answer is option B 1,3 dinitrobenzene. You know that when we treat nitrobenzene with HNO3 and H2SO4, this is a nitrating mixture, combination of HNO3 and H2SO4. Hence, when we treat nitrobenzene with nitrating mixture at 80 to 100 degrees Celsius, you will be getting meta nitro product. You will be getting meta nitro product because your nitrobenzene is, your nitro group is meta directing group because it is a electron withdrawing group. Hence it is meta directing. Hence you will be getting meta nitro product. Hence our answer will be 1,3 dinitrobenzene since nitro is Meta-directing, since nitro is meta-directing. If in place of nitro, if it was OCH3, then you will be getting ortho or para product, because it is a ortho para directing group. If there was OH or amine, then you will be getting ortho para product. Ortho para product. Question number 4. In the reaction, what is A? Which reagent is used for this conversion? Here they are given the option and try to find the perfect answer. Let us discuss the solution for this question. Answer is option C. Option C is the answer. For the conversion of diazonium chloride to benzene, you can see for the conversion of diazonium chloride to benzene, you will be using H3PO2 in water. Hence, in the present condition also, we can use the same. You can see here diazonium chloride is converted to benzene. There is no change of nitro or brome. Only diazonium chloride is converted to benzene. Hence, we can use the reagent, that is H3PO2 in water. H3PO2 in water. Question number 5. The following reaction is known by the name. Option A, acetylation. Option B, Scotton-Bowman reaction. Option C, Friedel-Crafts reaction. Option D, Perkins reaction. Try to find the answer. Let us discuss the solution for this question. This reaction is known as Scotton-Bowman reaction. Reaction of aniline with benzoyl chloride. Reaction of aniline with benzoyl chloride and in presence of NaOH is known as Scotton-Bowman reaction. Question number 6. Method by which aniline cannot be prepared is option A, reduction of nitrobenzene with H2 palladium in ethanol. Option B, potassium salt of phthalimide treated with chlorobenzene followed by hydrolysis with aqueous NaOH solution. Option C, hydrolysis of phenyl isocyanide with acidic solution. Option D, degradation of benzamide with the bromine in alkaline solution. Try to find the best answer. Let us discuss the solution for this question. Here we can do, it's an easy question. Answer is option B. Potassium salt of phthalimide treated with chlorobenzene followed by hydrolysis with aqueous NaOH solution. We know that if we use any other methods, reduction or hydrolysis or degradation, we can get the aniline. You can see this is a reduction. When nitrobenzene is reduced in presence of H2 palladium, you'll be getting aniline. Or if we treat phenyl isocyanide with hydrolysis, when we hydrolyze the phenyl isocyanide, you will be getting aniline. But when we do the degradation, this reaction is known as Hoffman bromamide reaction. When we do this reaction, you will end up with aniline. All these three reactions will give aniline except this option B, potassium salt of phthalimide treating with chlorobenzene followed by hydrolysis with NaOH solution. Hence, it is our answer. Question number 7. The product formed by the reaction of an aldehyde with the primary amine is option A, aromatic acid. option B skip base, option C ketone, and option D carboxylic acid. Try to find the answer. Let us discuss the solution for this question. Answer is skip base. When we treat aldehyde with a primary amine, this is a primary amine, this will act as a nucleophile. Hence, it will attack to electrophilic carbon. This carbon is electrophilic. Hence, this bond is shifted like this. Hence, it will be O minus. This O minus abstract a proton from nitrogen to give OH. This whole product is known as skip base. This whole product is known as skip base. Question number 8. A nitrogen containing organic compound given oily on heating with bromine and potassium hydroxide. It will give oily. On shaking the product with acetic anhydride, an antipyretic drug was obtained. And the reaction indicate the starting compound is option A acetamide, option B nitrobenzene, option C aniline, and option D benzamide. Try to find the answer. Let us discuss the solution for this question. Answer is benzamide. When we treat benzamide with bromine in KOH, this is a Hoffman degradation reaction. You will be getting aniline. This product is shaken with acetic anhydride. You will be getting acetanilide. That means it is a acetylation reaction. You will be getting acetanilide. It is a antipyretic drug. Remember, it is a antipyretic drug. Write down the reaction. Let us go to the next one. Question number 9. Ethyl chloride on heating with AgCN forms a compound X. The functional isomer of X is, there is a functional isomer for a X. What is that functional isomer? Try to find the best possible answer. Let us discuss the solution for this question. Answer is C2H5CN. When we treat ethyl chloride with AgCN, we will get ethyl isocyanide. And we have to find the functional isomer of ethyl isocyanide. It is ethyl cyanide. Both are functional isomers. Always ethyl cyanide and ethyl isocyanide is functional isomers. Question number 10. An example of sulfur containing amino acid is option A lysine, option B serine, option C cysteine, and option D tyrosine. Try to find the best possible answer. Let us discuss the solution for this question. Answer is cysteine. Here you can find the structure of cysteine. There is a presence of sulfur atom. Just write down the structure of cysteine. There is a presence of sulfur atom. Let us go to the next question. During the fusion of organic compound with the sodium metal, nitrogen atom of the compound is converted into during the fusion process. Let us discuss the solution. Answer is option C, sodium cyanide. Fusion test is nothing but here organic compound is taken with sodium in a fusion tube and you will be heating that tube. Now they are asking during that process nitrogen present in the compound is converted into what happens to the nitrogen present in the compound. If your compound is having nitrogen, it will be converted into which compound? They're telling nitrogen is converted into which compound. You can see any organic compound is having carbon, that's for sure, carbon. You are adding sodium and your compound is having carbon and nitrogen. Hence, sodium will combine with carbon and nitrogen to form sodium cyanide. Sodium cyanide. Question number 12. Which of the following would undergo Hoffman reaction to give primary amine? Let us discuss the solution for this question. Answer is option C. Remember, only primary amides will undergo Hoffman reaction. Here it was a acyl chloride. Now it is a secondary amide. This is a primary amide and this one is a ester. Ester will not undergo Hoffman or acyl chloride will not undergo, and secondary amide also will not undergo this Hoffman reaction. Only it is for primary amides. Primary amides. Question number 13. Hoffman's bromamide reaction is to convert option A amine to amide, option B amide to amine, option C alcohol to acid, and option D acid to alcohol. Let us discuss the solution. It is a conversion of amide to amine with a less number of carbon atom. Here amine is having one carbon less compared to starting amine. You can see here there was, if you imagine this R as a CH3, then there is a 2 carbon atom, but in the product is only 1 carbon atom. It's a conversion of amide to amine. Question number 14. The amino acid which is not optically active is option A glycine, option B alanine, and option C serine, option D lactic acid. Try to find the answer. Let us discuss the solution for this question. Answer is glycine. For a molecule to show optical activity, there should be the presence of chiral center. If you consider the structure of glycine, there is no chiral center. Chiral center means it is a center which is attached to all 4 different substituents. If we consider this as a chiral center, it cannot be, because in one side it is attached to NH2, COH, but it is attached to same hydrogen atoms. Hence, it cannot be chiral center. Question number 15. Maximum number of molecules of methyl iodide that can react with the molecule of CH3NH2 methylamine are option A 1, option B 2, option C 4, and option D 3. Try to find the best answer. Let us discuss the solution for this question. Answer is option D 3. Here methylamine react with the methyl iodide to give this product. Here there is two methyl groups attached. Again this will react with the methyl iodide to give tertiary amine. Again this tertiary amine will react with the methyl iodide to give quaternary amine. Hence there is a usage of 3 methyl iodide molecule. Hence our answer will be 3. Option D 3 is the right answer. Amines behave as option A Lewis acids, option B Lewis base, option C aprotic acid, and option D neutral compound. Try to find the best answer. Let us discuss the solution for this question. Answer is option B Lewis base, because any substance, any species which donates electron is known as Lewis base, and anything which accepts electron is known as Lewis acids. In the present case, ammonia will act as Lewis base because it is donating the electron, and BF3 will act as a Lewis acids because it is receiving the electron. Question number 17. There are 20 naturally occurring amino acids. The maximum number of tripeptides that can be obtained is. Find the best answer. Let us discuss the solution for this question. Each tripeptide involves 3 amino acid. For a formation of tripeptide, there should be a 3 amino acid. They are asking what is the maximum number of tripeptides formed by 20 amino acid. Hence it will be 20 to the power 3, it is 8000. Answer is option C 8000. Each tripeptide requires 3 amino acid. What's the maximum number of tripeptides can be formed from 20 amino acid? It is 8000. Question number 18. Which one of the following has the most nucleophilic nitrogen? Let us discuss the solution for this question. Anything which tend to donate the electron will act as nucleophile, and nucleophilic character increases with the tendency to donate the electron. If we consider the molecule, this molecule, these lone pairs are involved in resonance, hence they are not available for donation, hence its nucleophilic nature is less. If we consider this nitrogen is attached to carbonyl group. We know that this carbonyl is electron withdrawing. Hence it will not allow the donation of electron from nitrogen. Hence its nucleophilic nature is less. Here also this nitrogen, the lone pair present on this nitrogen is involved in the resonance. Hence it is not available for donation. But in case of pyridine, the lone pairs are not involved in the resonance. Hence it can easily donate the electron. Hence its nucleophilic nature is more. Question number 19. In alkaline medium, alanine exits predominantly as Option A, zwitterion. Option B, anion. Option C, covalent form. And option D, cation. Find the best answer. Let us discuss the solution for this question. Here there is a structure of alanine. There is a presence of basic amine group and acidic COOH group. When we take alanine in a basic solution, this OH minus will abstract this proton and it will give rise to anion. It will give rise to anion. Hence our option B, anion, is the right answer. Alanine exists in anionic form in a basic solution. In acidic solution, it will exist as a cation because this amine will abstract the proton and it will form positively charged nitrogen. Question number 20. Decomposition of benzene diazonium chloride using Cu2Cl2 in HCl to form chlorobenzene is the name of the reaction. Option A, Cannizaro's reaction. Option B, Kolb's reaction. Option C, Sandmeyer's reaction. And option D, Raschig's reaction. Let us discuss the solution for this question. Answer is Sandmeyer's reaction. Conversion of diazonium chloride to chlorobenzene in presence of CuCl and HCl is known as Sandmeyer's reaction. It's a Sandmeyer's reaction. Question number 21. Which of the following will be most stable diazonium salt? Most stable diazonium salt. Find the best possible answer. Let us discuss the solution for this question. Answer is option B. This is the answer. Since always positive charge on the atom is not stable, hence this N plus will gain the electron from benzene, because due to resonance this positively charged nitrogen will gain the electron due to resonance. Hence this molecule is highly stabilized. In all other molecules there is no presence of resonance. Hence this is highly stabilized or stable benzene diazonium chloride. Question number 22. The reaction of benzene diazonium chloride with aniline yields yellow dye. The name of the yellow dye is option A, para-hydroxyazobenzene. Option B, para-aminoazobenzene. Option C, para-nitroazobenzene. And option D, orthonitroazobenzene. Let us discuss the solution for this question. When benzene diazonium chloride reacts with aniline, it will give para-aminoazobenzene. Para-aminoazobenzene. Para-aminoazobenzene.